So for the pre-calculus, there are few topics which we need to cover. So this book also, I think it's also for, I couldn't remember, Canada-based one. Yeah, printed and bound in Canada. So they normally use this book for calculus things. So we'll start from this one and move and we'll complete this one. Maybe some chapters we have already covered. If so, we can move from them. Okay. So what will happen with the first chapter? If it is calculus, so first one we are going to talk about the patterns. First thing what we are going to talk about is the patterns. So normally when it comes to
It
pattern, huh?
possible to start with like the quadratic graph. I don't know.
So school starts with what?
It's possible to learn like that. Chapter 4,
Chapter
or the
4,
3,
quadratic
or 3,
equations.
or the 3.
3, that is quadratic functions. Are they starting with that?
With,
Okay, then shall I also start with this chapter 3?
yeah,
Okay. Then chapter 3 means here we have, is this the book what you guys are referring? No, right?
I know. My school didn't like start yet.
They don't have any textbook, I think. Okay.
They have textbook, but they don't show until like I start school.
Right. Okay. Okay. Once you get that book, send the cover page to me as well so that I can find the book by myself. Quadratic functions. Okay. So here it's in unit 3. No. Okay. Now here we have the unit 3. Now, so what are we going to do? Let me open this one. As you can see, enlarge. So here we are starting with the quadratic functions. Okay. Now, when it comes to quadratic functions, have you heard about quadratic functions?
Yes.
What are the things you know about quadratic functions?
The U shape.
Yes, U shape. It can be either U shape as well as it can be either V shape as well. So that's not the only thing. Let me get the paint as well. This one and with the size this third one. Okay, now I'm done. Now what will happen here for the quadratic functions? If you can read these stuffs, but I'll do kind of a summary thing. When it comes to quadratic functions, here an example for the quadratic function. Can you give me an example for the quadratic function?
Where?
So can you give me kind of an example for quadratic function? An equation? No. Okay. When it comes to quadratic function, so quadratic function means functions that it's like ax squared plus bx plus c type of an equation. So for example, ax squared plus bx plus c is equals to 0 type of an equation. We call them as quadratic equation. So there we have a few words to learn. One word is degree. One word is degree. So degree means what? The higher, so see in this equation, the highest power which is available on this equation is x squared, no? Which means the
Yeah.
power is 2. Then the degree of this equation will be 2. Okay. So a
Yeah.
quadratic function means an equation with the degree is 2. Degree is 2. If we say that it is degree is 2, then we should know it should start with x squared. Okay, it should start with x squared. Then the equation would be ax squared plus bx plus c is equals to 0 type of an equation. Is it clear?
Yeah.
That's
Yes.
what we have as the quadratic equation. So as you can read these entire stuffs later by yourself, but I'll do kind of a summary. So as they have told here, they have given us the simplest form of quadratic equation. That is, simplest form of the quadratic equation will be x squared as they have given. So px equals to x squared. Here the function is p and the quadratic equation is actually x squared. That would be the simplest example of a quadratic function. Okay. So what will happen for these kind of equations? We call them as quadratic equations. What about the linear equations? If it's a linear equation,
Straight
can
line.
you? Yes, if it's a linear equation, that means we can draw a line. No? Then the equation for a line would be y is equals to mx plus c. Okay, this is kind of a linear equation. This is not an quadratic equation. In a linear equation, the degree value is what?
Zero.
No, here we have one
One.
next term.
One.
Degree is 1. Okay, degree value is 1. So an equation, if its degree is 1, we call them as linear equations. But for the quadratic equations, the degree is 2. A general formula for degree, a general formula for these type of equations would be ax squared plus bx plus c is equals to 0. Is it clear?
Yes.
If the degree is 3, I'm just give you kind of a knowledge. If the degree is 3, then that equation starts from what? Ax cube plus bx squared plus cx plus d is equals to 0. Then for these kind of equations, we call them as cubic equations. So in here, we learned the linear equations, we learned the quadratic equations as well as the cubic equations. But for this chapter 3, the entire chapter, we are learning about these quadratic equations. Okay, it's clear, right, up to this point?
Yes.
Okay. Now what will happen? Now what will happen? There are few key terms. There are few key terms that we should know when we work with these quadratic equations. So here we have the quadratic function. We have to know about the quadratic functions, parabolas, vertex of the parabolas, minimal value, maximum value, axis of the symmetry. These are few terms which we are going to learn while doing this third unit, that is quadratic equation. Okay. Now if I move to the first part, that is investigating quadratic function in vertex form. Okay. So here, when it comes to vertex form, as I already told you, so this quadratic equation have kind of few forms. One form is vertex form. One form is vertex form. So for the vertex form, we are focusing on identifying quadratic functions in a vertex form and determine the effect of A, P, and Q on the graph, and also analyzing and graphing quadratic functions using these transformations. So what we are going to do here actually, okay. So here, do we have a note to explain you? Okay. So now, as they already said, if you read this one, um, okay. So if you read this one, so you can see that, so they have given kind of an equation. Okay, they have given kind of an equation. So, okay, first read this part. I mean, that would be, there's nothing. They have just explained kind of an scenario.
One will South Flats is a large area in the US and the remnant of an ancient lake from
Yeah, you can read
glacial.
it by yourself. No need to read it loud. That's fine. So just get the idea of what they are saying. The surface is extremely flat, smooth, and hard, making it an ideal place for researchers, racing enthusiastic, and automakers to test high speed vehicles in a safer manner. So now, what they are telling here is recently the salt flats have become the site of an annual time trial event for alternative fuel vehicles. At the 2007 event, one major automaker achieved a top um, what achieved a top speed of 335 with a blah 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 powered fuel cell car, the highest ever recorded land speed at the they have given that this scenario. It's understandable. Now what they're now what they're saying, suppose three vehicles are involved in a speed test. So we have three vehicles which they are focusing on the speed test. Then the first sits waiting at the start line in one test lane, while a second sits in 200 meters ahead in a second test line. Imagine now the case. These two cars are starting accelerating constantly at the same time. The third car leaves 5 seconds later from the start line in a third lane. The graph shows. Now, if they draw this entire scenario in a graph, they can draw like this. So these three curves belongs to those three vehicles. So one it waits for 5 seconds and start. That one would be the red one. Okay, and this one, these two initially start with the same time, but for the green color one is the one who is 200 meters ahead, right? So this one would be the green color one, the other one is the blue color one. These are the three vehicles actually, how they speed and how they go. So the function, how the function looks kyaneka, we have taken from this entire graph. Now what will happen? The graph shows a function for the distance traveled from the start line for each of the three vehicles. How are the algebraic forms of these functions related to each other? Now what will happen? For the red color one, they have given the function of this line. Okay, so they are comparing distance with the time, distance versus time graphs. Then for this one, red color one, they have given the equation as d is equals to 10 times t minus 5 square. That would be the equation for the red one. And for the blue color one, they have given that equation as d is equals to 10 t square. Then for the
So is this
third, uh,
so is this like the vertex one?
okay, vertex form is what? So as they have given us, vertex form is y is equals to a times x minus p squared plus q. If an quadratic equation written in this type of a format, if an quadratic equation have written in this format, we call them as the vertex form. Okay, if an quadratic equation, so if you check for the degree of this equation, so you can find that the degree will be 2, right? Because here degree will be 2, because here we have the highest x term would be x squared, which means the degree is 2. So if an quadratic equation in this format, we call them as the vertex form. That equation is in vertex form. If we wanted to convert any kind of what we call the any kind of a quadratic equation for a vertex form, we are doing this one in later. So up to now, you just have to know this is the vertex form of an quadratic equation. We'll do how we are going to convert these ones. Now what will happen? Here we have the third equation as d is equals to t 10 10 t squared plus 200. Okay. Now, can you comment on these three graphs? Who has the highest acceleration? Likewise, can you comment on these ones? What do you think? If you check for the acceleration, what do you think? Who has the highest acceleration? No comment?
How to find that?
Okay. We need to find anyway. That means we need to find, right? Okay, we'll move forward from the lesson. So I'll ask at the end again you to comment on these three equations. Is it clear up to this point? What we
Yes.
discussed? Okay. Now
Yeah.
what they are saying? Okay. Now what they are saying? Investigate graphs of quadratic functions in vertex form. Now what will happen? Compare the graph of fx is equals to x squared and fx is equals to ax squared. Now they have asked us to compare graphs type fx is equals to x squared and also fx is equals to ax squared. Okay, so first, what you have to do, just draw these two graphs. Fx is equals to x squared and fx is equals to 2x squared. Just draw these two graphs on in the same plane. Just draw these two. I'll get a graph into. Okay, if I also draw what they have asked us to draw, so the first equation is y is equals to x squared. Y is equals to x squared. You can see my screen, right? Okay, this will be the y is equals to x squared function. Now, if we draw for the y is equals to 2x squared, what do you think what will happen?
It's wider.
It's not wider. It's getting much closer to y-axis actually. So the blue color one is 2x squared. It's getting narrowed down. It's not getting wider. Okay. So what will happen? Now the red color graph is the x squared one. Y is equals to x squared one. Because here we are multiplying this entire x values by 2 now, which means it's again narrowed down, getting much closer to y-axis. Is it clear?
Yes.
What will happen if we have y is equals to 3x squared then? It's
get
getting
more narrow.
much more, yes, much more closer to y-axis. Is it clear now? What will happen? What what will happen when we multiply this x squared by a constant?
Yeah.
Okay, so here what we did, we just compared these two type of equations. So we compared what will happen if we multiplied this entire x squared function by a constant, positive constant. 2 is a positive constant. Now we'll see what will happen if we multiplied the x squared by half. Now the given function is y is equals to half. Y is equals to half of x squared. What do you think? What will happen? The purple color one
Wide.
is the purple color one is the half x squared. That means it's getting much more wider. Okay. Is
Yeah.
it clear how it works? When this
Yes.
were okay. Then what will happen? So these four, and also the next one would be what will happen. So we discussed about these three. Now what will happen if we multiply these one with minus values? Minus 1, minus 2, and minus half. What do you think what will happen? Any idea? So if I add this one, same thing, and then again, what we need to do now, the A value will be minus 1. So I'll put minus here. See, now what will happen? This entire graph got upside down, which means it's actually it will be a mirror, or it will be a reflection. It will be a reflection of y is equals to x squared by
Oh,
this x-axis. So here the red color one was the y is equals to x squared one. If you compare this y is equals to x squared graph as well as the y is equals to minus x squared one, both are symmetric actually. Both are symmetric by what? From the x-axis.
oh,
Is it clear?
yes.
Now the same thing happens. Now the same thing happens to the minus 2x squared. It will be the reflection of the positive 2x squared one. But what will happen? When it comes to minus 2x squared, again it will be much
Yeah.
more. Yes, it will
Same.
be getting much more closer to y-axis. It's not getting wider. It will be much more close to. It will be much more close to y-axis. Is it clear? Now the
Yes.
last one would be y is equals to minus half x squared. That is getting much more wider, but still it's the reflection of this positive half x squared function. Is it clear how this happens, how it varies?
Yeah.
Okay, that's how it is. Okay, that part it's done. Now they have asked, describe how the graph of each function compares to the graph of fx is equals to x squared using terms such as narrower, wider, and reflection. So as I told you here, we have to, when they ask us to explain this graph, okay, when they ask us to explain these graphs, you have to use these three words. Narrower, okay, narrower and also wider as well as the reflection. Is it clear?
Yeah.
You can comment, right?
Yeah.
Okay. So you can do that one. What relationship do you observe between the parameter A and the shape of the corresponding graph? What is the comment for that one? What relationship do you observe between the parameter A and the shape of the corresponding graph? So what do you think?
A is greater than
A?
1,
Uh,
then it become narrow.
yes. So that means actually if the A value is a positive value, then we have this kind of a U-shaped graph. If the A value is a negative value, then it will be a V-shaped one, which means here we have a minimum value graph. But here when the A value is minus, or when the A value is negative, then what will happen? Here we have the maximum value graph. Is it clear? So U-shaped
Yes.
one, we normally call them as a minimum value graph. But for the V-shaped one, we call them as maximum value graph. And what will happen when the A value is getting increased? If it's a positive way now, when the A value getting increased, so this U-shaped graph, the U-shaped graph getting much more closer to x-axis, right?
Yeah.
Much more closer to y-axis.
Yeah.
Okay. If it's half or like decimal point, if it's a zero, if this A value is in between 0 and 1, then it will be getting wider. That's how we should comment. Is it clear?
Yes.
Okay. Now if I move forward, okay. So here what will happen? Using a variety of values of A, write several of your own functions of form, include the both positive and negative values. You can do these ones neither. So what do you think? So what they have asked us to do, by using kind of a variety of values of A, then again they ask you to compare by yourself. It's like this. So same as what we have already done. And then they ask you to comment on positive and negative values. Okay, you can do this one. And for the third one, predict how the graph of these functions will compare to a graph of x squared. Test your prediction. Okay, that's fine. Reflect and respond. Okay, before moving to this. Okay, now we are moving to the theory part. Okay, so link the ideas. As I already told you, here we are learning about the quadratic functions. When it comes to quadratic functions, what we have to know, it's again kind of a polynomial equation. It's again kind of a polynomial equation, but with the degree 2, which means it would be ax squared plus bx plus c is equals to 0 type of an equation. Is it clear?
Yeah.
Then that part is here. Then, for example, they have given the simplest form of the quadratic function will be fx is equals to x squared. So this also we know already. Parabola means what we have already drawn here. For this kind of a shape, for this kind of a symmetrical curve of the graph of a quadratic function, we called it as parabola. Okay, so for this shape in mathematically, for this shape in maths, we call them as the parabola. Is it clear?
Yeah.
And your question was, what is vertex now? So vertex of a parabola means if it's a lowest graph, okay, if it's a lowest point graph, then the vertex would be the lowest point. If it's a
Oh,
maximum point graph, then the vertex point is the maximum point. Okay. So here
yeah.
we have so for example, this vertex means it's kind of a turning point. It's kind of a turning point. It can be either minimum or it can be either maximum. If it's a minimum graph, then it would be a minimum point. If it's a maximum point graph, then it has the maximum turning point or the maximum vertex. Is it clear?
Yes.
Okay. That's what they are saying here. The lowest point of the graph, if the graph opens upward, or the highest point of the graph if the graph opens downward. That's what they have given here. Is it clear?
Yes.
Now, the graph of the quadratic function is a parabola. So, we already learned. When the graph opens upward, the vertex is the lowest point on the graph. When the graph opens the downward, when the graphs open the downward, the vertex is the highest point on the graph. So that's what here we have already learned. And then when using function notations, how we gonna define this one? How we use the function notation? When using the function notation, the values for fx, y means y values are actually the function values. The values what we have for fx. The values for fx are often considered the same as the values for y. Y means actually function value, function of x. Is it clear?
Yeah.
That's what there we have. Now we are going to talk about the minimum value and the maximum value. Okay. So if the y coordinate of the vertex, so what would be the minimum value? Minimum value is the y coordinate of this vertex. If it's either minimum value or the maximum value, it can be only a y coordinate. So the y coordinate of the vertex is called the minimum value if the parabola opens upwards. We called this value as the maximum one. Again, the y coordinate of the vertex is called the maximum value if the parabola opens the downward. Is it clear?
Yeah.
Always minimum value or the maximum value is only a y coordinate, the function value. It's not x coordinate.
Yeah.
Okay. Okay. Now what will happen? Here we are going to learn about the axis of symmetry. So the parabola is symmetric about a line called the axis of symmetry. If we draw the graph like this, now how the symmetric line works? The symmetric line always go through the vertex. Okay? The symmetric line always go through the vertex. So here we have the symmetric line like this. If I draw a line like this, then what would be the equation for the symmetric line? That is x is equals to 3. Is it clear? So likewise, so if you check for this graph here, the vertex coordinates are 3, 1. Here 3 is the x coordinate, 1 is the y coordinate. Then if I draw this symmetric line, it goes towards the vertex, which means the symmetric line is x is equals to 3. Okay, so for any given graph, you should be able to find out the minimum value, maximum value, the symmetric line. So those are the few things we should know to comment on these graphs. Okay, so here,
Oh, it happens.
yeah, it's understandable, right?
Yeah.
Okay, the parabola is symmetric about a line called the axis of symmetry. This line divides the function graph into two parts so that the graph on one side is the mirror image of the graph of the other side. So this means that if you know a point on one side of the parabola, you can determine the corresponding point on the other side based on the axis of the symmetry. So the axis of symmetry intersects the parabola at the vertex. As I told you here, the axis of the symmetry intersects the parabola at the vertex point. Vertex. The x-coordinates of the vertex corresponds to the equation of the axis of the symmetry. Okay, that's how up to this point what we have already learned. So here they have given few things: minimum value of a function, the least value in the function range of a function for a quadratic function that opens upward, the y coordinates. We already discussed these ones. They have given kind of a summary. Is it clear up to this point?
Yeah.
Now what we are going to do, now we are converting any kind of a quadratic function to a vertex form. So quadratic functions written in vertex form, it will looks like this. As I told you earlier, function of x is equals to a times x minus p squared plus q. That's how the vertex form works. Are useful when graphing the function. The vertex form tells you the location of the vertex. Now we should know the terms of this equation. So here the coordinates, location of the vertex, the coordinates of the vertex will be PQ. So here we have the x coordinate, here we have the y coordinate, as well as the shape of the parabola and the direction of the opening. You can examine the parameters a, p, and q to determine information about the graph. Now, how we are going to convert this kind of a one? Okay, now how we are going to convert? So here a times x minus p squared plus q. If they have given us the vertex, we can directly, so for example, here they have given us the vertex as 3, 1. Then we can rewrite this equation, quadratic function equation in vertex form. That would be fx is equals to a times x minus 3 squared plus 1. So only thing we need to find out is the value of a. Is it clear?
Yeah.
Oh. Now the effect of parameter a in fx is equals to ax squared on the graph of fx is equals to x squared. So we already discussed this part. So consider the graph of following functions. So fx is equals to x squared. We also drawn that one. What will happen if it's 0.5x squared? Then it will be getting much more wider. But still, the symmetric line is what? Symmetric line is y-axis. When x is equals to 0 will be the symmetric line. So you should be able to comment on these ones. How? The parabola is wider in relation to the y-axis than fx is equals to x squared. So it's getting much more wider. But for the minus 3x squared, what will happen? It will be getting more narrower. Okay, it will be the red color one is that graph. It will be getting much more narrower in relation to the y-axis than fx is equals to x squared. But since here we have minus, what will happen here? It opens downward. It opens downwards. But for the previous one, here we had the value a as positive. Because of that, it opens upward. So you should be able to use these words terms, mathematical terms correctly when you are describing the graph. Is it clear?
Yes.
Okay. The parameter A determines the orientation and shape of the parabola. Okay. Parameter A determines the orientation and the shape, whether it's opens upwards or whether it opens downwards. The graph opens upwards if A is a positive value. If A is a positive value, then it opens upwards. If it's a negative, then it opens downwards. Now what will happen? If the parabola is if the value a, if the a value is in between -1 and +1, okay, -1 and +1, then what will happen? The parabola is wider compared to the graph y is equals to x squared. But if it's greater than 1 or less than -1, then it will be narrower. It will be getting much more narrow. Is it clear?
Yes.
Okay. Now what will happen? Because you these ones you should be able to now identify. Why? The reason is we have already done this transformation in trigonometry. Can you remember? We did the same thing. So we did y is equals to sine theta. We drew y is equals to sine theta. And what we did, then we did y is equals to sine theta plus 1. So we drew all these kind of graphs. No? The same
Yeah.
thing we are doing for this quadratic equations. Okay, the same thing, same set of things. Now the next one. Okay, can you do one thing? Okay, by looking at this, explain me what. So you should be able to understand now. By looking at this part, what they are telling. So explain me from your words. It's easy. So now earlier we just compared fx is equals to x squared and fx is equals to ax squared. Now we are going to compare these two type of equations. Okay, now we are going to compare what? Now we are going to compare fx is equals to x squared and fx is equals to x squared plus q. These two type of equations. Explain me what will happen here in your work.
Plus Q value is positive, it goes up. You
Yes.
shift the graph. If the plus Q value, if Q value is negative, you shift down.
Yes. That's what you should know, right? The graph is translated 5 units up. If it's +5, the Q value is plus. Then if the Q value is minus, then the graph is translated 4 units down. That's what here they have given. But still, the symmetric line is not changing. Only thing is the same graph shifted, the same graph will shifted up or shifted down. Is it clear?
Yes.
Okay. Now tell me the effect of parameter p in fx is equals to x minus p squared on the graph of fx is equals to x squared. For this one. For this one, I think, okay. Try this one as well. What do you think? By looking at this entire thing, what do you feel? Same as the previous one.
P value is negative, shift left. P value is positive, shift right.
No. The other way. If
So
the
P value is
ah Same thing happens in trigonometry as well. If this -1, then it's shifted to where?
Right.
Right. It's shifted to right. If it's +3, then it
Left.
shifted to left. Is it clear?
Yeah.
Okay. What will happen here? They have given fx is equal to x squared. So fx is equals to x minus 1 squared and x plus 3 squared. What will happen? Here, if the p value is plus, then it will be shifted right. If the p value is minus, then it will be shifted to, sorry, if the p value is plus, then it will be shifted to left. If the p value is negative, it will be shifted to right. That's how it works. How do we think on that one? That is, so we are comparing these equations with x squared, no? So to become this part, okay, to become this part, okay, so here we have fx is equals to x minus 1 square. So what will happen? To become this one as x squared, what we have to do? We just need to add 1. So here we have x minus 1. So here we have x. To make this x minus 1 x, what we need to do? We just need to add 1. No? That means here it will be shifted to right side because we are adding 1. But in the next equation, there we have x plus 3 squared. No? X plus 3 squared to become its to, to become its x squared. Now what will happen? We just need to subtract 3 units, right?
Yeah.
Subtract 3 units, which means that one should move to the left side. That's
Yeah.
how I normally recall and remember this thing. Whatever is okay with you, you can just recall for that method. Is it clear up to this point what we have done?
Yes.
Okay.
Yeah.
Now we are going to combine in transformations. Okay. My question is, don't look at this one. Try to draw these two, the final question. Now we have done all these things. First, you can draw this y is equals to x squared, starting with y is equals to x squared, and then translate and then convert that x squared equation, x squared graph into this one. Minus 2 times x minus 3 squared plus 1. So first, the steps would be, first you need to draw y is equals to x squared. Okay. And then you need to draw y is equals to x minus 3 squared. Okay. And then you need to draw y is equals to minus 2 times x minus 3 squared.
Yeah.
And the last one would be y is equals to minus 2 times x minus 3 squared plus 1. Is it clear? So
Yeah.
try to draw these ones starting with x squared. You should be able to draw the final curve for this one. You need to follow these steps. Okay, draw, start. It's clear, right, up to this point? If you
You
have
can't
any,
like
huh?
you can't like use any like calculator, no.
Sorry,
Or no, right.
I didn't get you.
You have to draw like that.
You should draw, yes. So starting from y is equals to x squared, you should be able to draw this one. You're asking how to draw, is it?
No, no.
Then okay, just draw and send me. Try that one. You are doing right?
Yeah.
Okay.
Wait, I have a question.
Yes, ask.
But minus 2 square, like for the fx equals x square,
Mm.
minus 2 square is like 4, right?
Okay.
And why is there like number on the left side?
Yes, minus 2. So what will happen then? The curve will be, so the curve will be, so earlier the curve will be open upwards. And for the x minus 3 squared means, again, it will be shifted, this curve will be shifted to 3 for the right side. Then if I multiply this one by minus 2, then it will become negative in the sense it will become what it will become a graph that opens to the downwards, and here it's minus 2, no? Minus 2 means then it will be getting much more narrowed down, because narrow down with the y-axis. Let me show you how it happens. Let me show you. See, now we have the y is equals to x squared. Now what will happen? Then, as I told you, you have to draw y is equals to x minus 3, x minus 3 squared. Okay, x minus 3 squared will be like this. Now what will happen? Then the next step would be actually y is equals to minus this one. See, now it will be, so the same graph will reflect, reflect or mirror by the x-axis. Then you can draw y is equals to minus 2 times minus 2x minus 3 square. That means the black color one. It's getting much more narrowed down. Okay. Then
Yeah.
we have, then what we need to do, we just need to add what? The last one would be, we just need to, it will become plus 1. Then here we have plus 1. See, plus 1 means it will be shifted up from 1. Okay?
Oh, okay.
Okay. Now complete your entire working.
Oh. Okay, I do.
Okay. So then that is it.
When you do this in the school, you don't use any
Which one?
like you can just put numbers for x and just dot.
Okay. Um, which means,
Hmm?
so what's the question again? Ask.
Like, can I do like this? Would say like x is 3 and 3 minus 3 is 0, minus 2, 0, plus 1, like that.
Mm, no, because no means actually. Um, so you can't do like that because you should follow this step. Why? The reason is, so you just ask whether we can what? Again ask. Sorry.
Put numbers like 3 minus 3,
Ah, okay.
2.
You just ask whether, right, good question. So can we draw by substituting numbers, right? With the data table or something? Is it the question?
Yeah.
No, you can't. Because the reason is we don't know the vertex is no. To find out what would be the exact minimum point, we should follow this method. So otherwise we can curve this graph from here, or else we can curve this graph from here. How do we know what would be the minimum or the maximum value? So because of that, we can substitute and get few points. Yes, that's true. But how do we know from where it would be turned? It would be turned or whatever. Here. Is it clear?
Yeah.
Because of that, we should follow this entire method. So in general, the sign of defines the direction of opening of the parabola when a is greater than 0, the graph opens upward, and when a is less than 0, the graph opens downwards. Then the parameter a also determines how wide or narrow the
Yeah.
graph is compared to the graph of fx is equals to x squared. The point PQ defines the vertex of the parabola, and the equation x is equals to P defines the axis. So here we have the matrix axis. So matrix axis is what? X is equals to 3. That's clear, right?
Mm.
Okay. Now sketch the graph of quadratic functions in vertex form. Okay, they have given the equations now. Okay. Your question also there. How do we sketch by using points? Okay. Can you draw one? Okay. We did this kind of one. Can you draw this one only? Y is equals to minus half x minus 4 squared plus 1. And then we'll discuss about the vertex, domain, range, and the direction of the openings. So remember, if they ask us to describe the graph or explain the graph, to you need to explain these 4 points. So you should be able to identify and express the vertex, and then you need to tell about the domain and the range, and then the direction of the opening, whether it's upward or downwards, and also what would be the symmetric axis of the symmetric. So you need to provide answers for all these 4 points. Okay. Is it clear? So I'll explain what would be the domain and range. Okay. So just start drawing this one, and then we'll move to the next part, next theory part. Hello.
So,
Uh-huh. Yeah, you can draw. You can draw. That's fine. No, no, me.
We're done. Hello. I'm done.
Okay, so do I need to draw the graph and show you how it works?
Okay, yeah.
Okay, so first, how it works. So the method would be, first you need to draw y is equals to x squared. Okay, then you need to draw, okay, first you need to draw y is equals to x squared. Then you need to draw y is equals to x minus 4 squared. Okay, then x minus 4 squared. X minus 4 squared. Then what you need to do, so x minus 4 squared means it has been moved from 4 units to the right side. That's clear now? Then you need to draw y is equals to minus x minus 4 squared. And then you can draw y is equals to minus half. Not half, 1 over 4, I think. 1 over 4. So this will be like this. Okay? Then you can add 1. Add 1 means the entire graph is shifted up from 1 unit. The black color one is the correct graph. Is it clear?
Yeah.
Okay, that's how it works. So then, now that part is done. Then the solution, they have given the entire solution how you should explain these stuffs, explain these
You have to like
stuff.
draw it one by one.
Sorry?
So when you draw it, you have to draw like slowly, like first x square, then x minus 4.
Yeah. No, you don't wanted to show all these steps at the exam. So you asked me to draw it again.
You like draw it right away, like straight, like plug the numbers and
Yeah,
just
you can draw it. You can draw it with the numbers directly. Yes, you can draw the You can draw with the numbers directly. No need to draw all these ones, but it's better if you can draw because they have also drawn. So this is how they have also shown it. So first they have drawn y is for the first question. The question is y is equals to this one. First they have drawn y is equals to x squared. Then what they have drawn is y is equals to 2x squared. But my opinion is first it's better if you draw x plus 1 squared and then multiply that entire equation by 2. So which means again it will be getting narrower down. Then what you can do, this one is the 2 times x plus 1 squared. Then you can subtract. So here we have minus 3, minus 3. 3 means the graph will be shifted down from 3 units. Then this is the final graph. Okay, is it clear?
yeah,
Okay.
yeah.
Yeah. Now, the second method is method 2 is sketch using points and symmetry. This is your question. So now what they have done, they have given the question like this. Plot the coordinates of the vertex. Vertex is given minus 1, minus 3 and draw the axis of symmetry, that is x is equals to minus 1. Determine the coordinates of one other point on the parabola. Now how it works. So first what you need to do, so now we have the vertex, no? We have the coordinates of vertex. Then we know the symmetric line as well. Symmetric line is x is equals to minus 1. Then we have those informations up to this point. Now, the second method would be, so we need to find out another few points. So if they have given us the vertex, then what we need to do, we need to find out another points. The easiest point which we can find is when x is equals to 2. So what we can do, we can use the given function and then we can substitute value 0 here instead of this x and find out the value y. Then when x is equals to 0, the y value would be minus 1. So the coordinates are 0, minus 1. The vertex coordinate is minus 1, minus 3. So what else? Since this entire graph symmetric on x is equals to minus 1, then what you can do? Then what you
Mm,
can do? You can find out another, not you can find out another what we call, you can find out another coordinate. What would be the other coordinate? So this one is 0, minus 1. And the symmetric line is when x is equals to minus 1. So to find out the other coordinate, so for example, here we have 0, minus 1. 0, minus 1 is here. So we have the symmetric line like this. Then to find out the other coordinate, what we need to do? The y value is not getting changed. Y value will become same. But here, here we had 0, 0. The symmetric line is minus 1. Then the gap would be 1, which means the other x coordinate is minus 2. Is it clear?
yeah. So one space out. Same
Yes.
X,
Yes.
Y.
Sorry?
It's the same Y coordinate.
Same y. Yes, because it's symmetric, no? Then symmetric with this x is equals to minus 1. X is equals to minus 1 line means this. So symmetric means these 2 points are symmetric. So y value is not getting changed. Only x value getting changed.
Yeah.
Yeah. Then these, we have 3 points. So what we can do? We can draw the graph. So we can roughly draw the graph. If you want kind of a proper graph, then you can find out the roots. Root means actually when y is equals to 0. We can find out the values when y is equals to 0 and check for the roots. Roots means actually what? Root means the values, it intersect the x-axis. There we have y is equals to 0. If we equalize y is equals to 0, then you can find out those two x coordinates. So now
So
you have uh,
you said roots intersect with the
roots,
X
roots.
axis.
Yes, 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 roots. Where it's the curve intercepts the x-axis. We call them as roots. So we can find out these 2 points. Then we have 5 points altogether. So we can draw this graph easily. Is it clear?
Yes.
Okay.
Minimum, how many points you need?
Minimum 3 points will be enough. Minimum 3 points will be enough, but it's better if you have 5. 5 means the special cases. Normally, we are finding the points when x is equals to 0. And also we are finding the points when y is equals to 0. When y is equals to 0, we are getting 2 points. Okay, we are getting 2 points. And also we have the vertex as well. We
Yeah.
have the vertex. So, and also what we have the vertex. So here we have altogether 4 points. So if we have the if we have the vertex, that means we have the symmetric line as well. So we can draw the symmetric line. From that, we can have the, if we know this point, then we can find out the other symmetric point as well. Likewise. The minimum points will be when x is equals to 0, and also when y is equals to 0. There we can have 2 points and the vertex. 4 points are there. Okay?
Yes.
Okay. Now we did this one. Okay, your turn. Your turn in the sense you can draw. Okay, you can you have to do all these ones. I mean, you have to describe these ones: the vertex, domain, and the range. Okay, domain means what?
X.
Yes, domain means the exact x values which we input for these ones. And what about the range? Range means
Changes the Y.
y values. Yes, the output y values. Then, yes, then the symmetric as well. Okay, that is done. Example 2, determine a quadratic function in vertex form. Okay, now you have a question. So they have given us these two graphs. We need to find out the equation. Can you try to do that one? First one. This is the graph. This is the graph. You need to find out the equation of this graph. So you have the vertex. Okay. And also, so you have the coordinates of the vertex. And also you have the roots. When y is equals to 0, what are the x coordinates? Try to find out the equation of this one. Try to find out the equation of this one.
I think the first one is 1/3.
Y is equals to
1/3.
1/3
x minus 5, x
x
plus
x minus 5 x minus 5, okay, x minus 5 squared
minus 4.
minus 4. Okay, so let me check. If I put x is equals to 2, x is equals to 2, the y value would be 0. How it happens? So here, when x is equals to 2, 2 minus 5, 2 minus 5, that is minus 3. Minus 3 squared. No, it's not getting, it's not, this is not the equation. Because if you substitute x is equals to 2, okay, y is equals to 1 over third 2 minus
Wait, is it x plus 5?
so what will happen? X, let me check. X minus 5 squared minus 4. No? Then here we have x minus 5 means minus 3 squared 9. 9 over 3, that is 3. 3 minus 4, no, minus 1. No, 0 is not there. Here x plus 5. X plus 5 again. X plus 5. Okay, x plus 5. No, 2 plus 5, that is then 7. No, it's also no. No, it's also not. The easiest method is first write the uh, general formula of the equation. That is y is equals to, what would be the general formula? A times x minus, what was the general formula? That my x minus p, right? X minus p is oh, where am I going? Okay, here. X minus p squared plus q, no? This one is the general one. Now here p and q are the coordinates of the vertex. That's what we had. Now, so p is actually what? Then the p should be the x coordinate, that is 5. Yes, you are correct. Q is the y coordinate. Okay, y coordinate of that one. Then, which means here y is minus 4. That's correct. Then you have the modified one. Y is equals to a times x minus 5 squared minus 4. That is it. Is it clear? Now what we
Yeah.
need to do, we need to find out the value a. No? The best way is
Yeah.
you can just substitute one value. No? So here we can read one point of this curve. So the easiest point is, see here 0, 4. 0, 4 is a point on this curve. No? That means when x is equals to 0, the y value would be 4. So what I normally do, I just substitute that one here. So y value 4 is equals to a times. Now the x value is 0. 0 minus 5 squared means here we have 25. 25 minus 4. Okay. Then this 4 I'll bring into the left hand side. Then that is 8. Okay. 8 over 25 is 8. So the value is 8. Is it clear?
Yes.
Okay, now you can rewrite the equation as, okay, if I rewrite that equation, let me show you. If I rewrite this equation, how it works. Y is equals to 8 over 25 x minus 5 squared plus minus 4, right? Minus 4. This is what I receive. Let me check whether it's correct. If I substitute if I substitute 5, if I substitute 5, oh, it's not. If I substitute 5 here, again, it's not correct, right?
Yeah.
Oh, why is that? So, what I did first, when it comes to 0, okay, if I substitute x is 0, the y value is not 4. How can I do that easily? If we can read a point perfectly, then, see, they have marked those points to use. So if you check, so this one is the point. See, they have marked 3 points. Vertex, one point is vertex and these 2 points. See, they have marked that one, which means when x is equals to 2, the y value is minus 1. So when the x value is 2, when x is equals to 2, the y value is minus 1. Okay. So then
Yeah.
just check for the a. Y is equals to a times x minus 5 squared minus 4. There we have, when x is equals to 2, 2 minus 5 squared minus 4, a is equals to y value is minus 1. So minus 1, if I bring this minus 4 to this side, then we have 3. 3 is equals to, here we have 3 squared, minus 3 squared means 9, 9a. Then a is 1 over 3. A is 1 over 3. You told me that one, right?
Yeah.
Okay, then what will happen? Okay, 1 over 3. Okay, then which means, let me check. So if we have the equation as y is equals to 1 over 3, x minus 5 squared minus 4. Now the vertex is 5 minus 4. That is correct. 5 minus 4, that is correct. If I substitute 2 here, 2 here, if I substitute 2 here, 2 minus 5 squared, 2 minus 5 means minus 3 squared, 9. 9 over 3, that is 3. Okay, that one also correct. Here, if I substitute 8, what will happen? If I substitute 8, 8 minus 5, that is again 3. 3 squared is 9. Again minus 1. Yeah, then this equation is correct. Sorry.
Oh, right.
You know, right, how to do this now? You can just use
Yes.
the vertex and roughly,
Why can't use 0, 4?
sorry?
Why can we use 0, 4?
0 for no need to use because it's not actually, it's not intersect the 4. It's kind of 4.2 or something. That's why they have marked these 3 points to use. So they have marked these exact points to use, no?
Oh,
Okay. So here they haven't marked because it is not actually 4. The y value is not actually 4 there. Okay.
yeah.
Okay. Then that is clear now. Okay. You can do the rest. Yes. You can do the rest. And then here we have, Okay, now the method 2, compare with the graph of fx is equals to x squared. Now what they are? Okay, you can do this one as well, no? The solutions they have given. Okay, then the example 3 also there. Okay, the solution again, this one. Example 4 question also there they have given, so you can do those ones. Key ideas, that's all. Key ideas and the check your understandings. You have to have the practice questions. You have to do the practice questions. That's
This
all.
book.
Yeah, that's all for the no, that's all for the third unit actually. So you have to do the, yeah, that's all. No, that's all for the 3.1 only. Then we have to move for the 3.2. Okay. So is it clear what we have done so far? Hello.
Yeah.
Is it clear what we have done so far? Okay. So if I go with these ones, so here we have the third unit. No.
Will you give question or
Huh?
will you give like question or no?
Okay, we'll do few questions. So here I'm I just wanted to summarize these ones. Okay, this part we already done. Shall we do one or two questions and then move to the second part? Okay. Now these ones it's clear for you, no? Okay.
Yeah.
Then okay, these ones we already did. Fx is equals to, okay, this one. Your turn. Okay. Just do these two as well. Try to find the question. Try to find the equation. These two. Try to find the equation of these two.
Okay, B1 is
First one is what?
what I didn't do first. I did the second.
I you did the second one. Ah, okay. What would be the second one?
4x minus 2 square plus
Y is equals to x minus 2 complete squared plus 2.
plus 1.
Uh,
I said 4x minus 2 square.
oh.
4. 4x minus 2.
Mhm. 4x minus 2 squared plus 1, right?
Yeah. That's it.
Okay. If I substitute 2, 2 minus 2, 0, 2 minus 2, 0, then this part becomes 0, then that value is 1. Yes, correct. If I substitute 1, 1 minus 2, that is minus 1 squared 1, that is 4, 4 plus 1, that is 5. Oh, yes, very good. Then if I substitute 3, 3 minus 2, that is 1, 1 squared again 4. Yes, yes, you're correct. Then this one, A, A.
Okay. So do A.
A. Yes, first
So
one.
B is right.
Hmm.
Means minus half.
Uh, minus half.
uh,
So how it works?
Y equal minus half x plus 3 square.
Y equals minus half
X plus 3 square.
x plus 3 squared. Then that's
Plus
all.
0. Yeah.
Plus 0. Okay. So if I substitute minus 3, then the value is yes, correct. And then here, if I substitute minus 5, okay, if I substitute minus 5, what will happen? Minus 5 plus 3 squared into minus half. No. Then here we have minus 5 plus 3 means minus 2 squared, that is 4. 4 into minus half, that is minus 2. Yes, correct. Then if I substitute minus 1 plus 3, that is 2. 2 squared is 4. 4 times minus half is again minus 2. Yes, correct. And also if I check with the other one, when, okay, yes, your answer is correct. Now you know, right, how to do this type of questions?
Yeah.
Okay.
Yeah.
Okay. So go through with all these ones. Go through with all these ones means, so see, for the first question, they have drawn this kind of a table and explain how the values are changing, according to a q, and how the visualization goes and the x intercept works. So this is how they interpret. Okay, follow all these steps. What we have done is the same thing, but they have nicely presented it. So follow these ones as well. When A is positive, then the graph will open upwards. Likewise, you should be able to explain these ones. Okay?
Yeah.
Okay. Then you have to do all these examples. Okay, we'll do this one. Draw a diagram and label it with the given, yeah, the exam. Okay. Draw the set of x-axis, okay, coordinates, since the vertex is located. Okay, now for this one, example 4. Model problems using quadratic functions in vertex form. This is a real time, again, so this is kind of a real scenario you need to address. And then by understanding this one, you need to provide a solution in the sense you need to um, generate or define a quadratic function in vertex form. Okay, try to do this kind of a question. Example 4.
How do you do it?
Think a little bit. So what it says, the deck of the Lions Gate bridge in Vancouver is suspended from two main cables attached to the tops of two supporting towers. Between the towers, the main cables take the shape of the parabola as they support the weight of the deck. The towers are 111 meters tall relative to the water's surface and are 472 meters apart. The lowest point of the cable is approximately 67. See, they have given the minimum point as well as they have given another 2 points. Model the shape of the cables with a quadratic function in vertex form. So they have given kind of a help as well. Model the shape of the cables with a quadratic function. The deck of the Lionsgate Bridge in Vancouver is suspended from two main cables attached to the tops of two supporting towers. Between the towers, the main cables take the shape of a parabola as they support the weight of the deck. The towers are 111 meters tall relative to the water's surface and are 472 meters apart. Okay, the distance will be in between these two 472. So the the height would be 111 relative to the water surface and are 407. The lowest point of this cable is approximately 67. Okay, here we have the 67, the lowest point. So
7? 67?
67, 67, yeah. Then the lowest point would be the 67. Now they ask us to model the shape of the cables with a quadratic function in vertex form. So how do we think? Draw a diagram and label it with the given information. How do we gonna think this one? I'll go through with the solution and explain. So it will help you to understand it properly. How we gonna think about these type of questions? That is, let the vertex of the parabolic shape be at the low point of the cables. Consider this point to be the origin. So what they are telling is, why is this point the simplest to use as the origin? So what they are telling is, so they have asked to consider this point as the origin. So the low
Mm.
point of the cables, lowest point of the cable. So this would be kind of symmetric because of that. It will be in the middle now.
Yeah.
Then what will happen? Draw a set of axes. Let x and y represent the horizontal and the vertical distances from the low point of the cables respectively. So here we have the x-axis, the distance matters. Here we have the y-axis, the tall or the height matters. Now, see, here we have a sketch for that one. So we have the origin 0, 0. Okay, we have the origin 0, 0. Okay, then draw a set of axes. How it works? Now we have the entire distance as well, 472. If we mark this one as the y-axis, which means the middle point, 0, 0 as the origin, then for this side, right side, we have 236. For the left side, we have minus 236.
So it's the half. So you divide the 472 by 2
So, yes,
to
yes.
get the.
Yes, it's
Oh,
472 divided by 2 because it's in the middle. So here then we have the x coordinate as 236. here the x coordinate compared to this marked origin, it will be minus 236. Is it clear?
Yeah.
Then the height is, they have given that 111. So both lamps or both things, the height would be 111.
Yeah.
Okay, because we are using the same thing. That one also done.
Yeah.
Now what is this 67? 67 means what? So 67 is this point. This point means what is 67 as they have shown us. So 67 is, so now 67 is actually the lowest point of the cables is approximately 67 meters above the water surface. There we have the water surface as well. That's why they have marked this water surface like this. See,
So
this is
water
the
surface is like
water surface.
X.
Yeah, water surface is the X. See, is it clear? Water
Yeah.
surface is X, then what will happen? From that, from this X, then we have 67 here. The
Okay.
minimum point will be 67. So which means here we have the value that is 0 minus 67 because x-axis is the water surface. If we count 67 down, then it is minus 67. Is it clear?
Yeah.
Okay. Now we have so many points, right? So since this one is minus 67, so this height is 44 because the entire total should adds up to, these two heights should adds up to 111. Because of that, 111 is this entire height. This part will be 67. So this part will be 44. Is it clear?
So is it 67 below the x-axis?
Yeah, below
Or
the
is it?
x-axis. Yes, below the
But
x-axis
still.
because they have given that fact now. See, the lowest point of the cable is approximately 67 meters above the water surface.
Oh.
So they have given that part.
Okay.
So which means this part will be 67. So this part will be 44. Okay, now can you draw? Now it's easily can be drawn. Now it can be easily drawn. Try to draw the graph now.
So draw this graph.
Yes, you drew.
Yeah. How
Okay.
do you draw like? Okay.
Sorry.
Okay.
First, you need to find out the equation. If you want, you can find out the equation and then draw, or else you have almost all the facts because we have the vertex point and we have these points as well. So we know the minimum point and the graph will be like open upwards. So all those informations are there.
Yeah,
You
but
can. Uh, okay.
but
Give
we
me
don't know like the A.
1 minute. Okay. What's your question? Yeah, what was your question? Did you ask a question from me?
You have to find like the A, right? I think.
Yes, yes. But anyway, that can be found no, because we have 2 points. Because
Okay.
first
Okay.
what you, yeah, we have 2 points. No? So we can roughly first rewrite this equation that is fx is equals to a times x minus, sorry, yeah, x minus p squared, right? P squared plus q. Then we can find out p and q. We know the values for p and q. And then you can substitute one single point.
Okay, but it's like a very odd number. It's like 0.12 something.
Yes. So all these answers are like that. See, is in decimal terms. Yeah, that's fine. Anyway, no need to draw. You clear about what you have to draw, right? What you have to do
Yeah.
such kind of questions.
Yeah.
Okay, then that is done. Then you have to do these ones. I already sent you this entire book. So please go through with the first example and also each and every example, tried it. If they have given you the solutions, then what you can do, you can go through with all the solutions. Because of that, you can learn how to answer, how to write all these answers at the exam, during the exam. So it will help you to find out the method. It will not, then if you follow all those steps, it will not, you will not be able to miss those steps. That's why. Okay. Then do all these practice questions. There you have the check your understandings. So there you have all these questions until yes, here you have like so many questions there. Here you have up to 23 questions, and then you need to start with this. You need to start with the create connections part, uh, and then yeah, you can complete this entire 3.1 section. Okay, so yeah, we need to do the 3.2 then. What do you think? Yeah, now it's almost 10:30. We have done almost 2.5 hours. So you can complete this entire one. Then we'll start the second section next day, tomorrow. Okay? Is it
Yeah.
fine? Okay,
Yeah.
okay. Hope you can understand. You were able to understand this entire thing. And see you tomorrow. We'll we'll start 3.2 tomorrow.
Yeah.
Okay?
Okay.
Okay. See you. Bye.
Bye.